Okay, so TensorFlow, you already know, it's a library created by Google. And it has all this nice neural network, deep learning models and algorithm or the code that you can actually apply to use. So that's the fundamental library for most of the AI things we're doing today. Now, TensorFlow Lite, just from the name, you can see is a sub-project from TensorFlow. And since it's called Lite, it just means that the models here is smaller, is easier to use. But of course, when it gets smaller, maybe it gets a little bit less powerful. Because if it's a smaller, it means that the model maybe doesn't have as much information as the regular size. But why do we still need this? Because you can see we can apply this one on some of the special devices. Instead of running the prediction on the computer, we can run this on the phone. We can run this on some of the hardware pieces, for example, inside a car, or maybe, I don't know if you use Raspberry Pi, but we can also run this one in the Raspberry Pi.
I have never used Raspberry Pi before.
Yeah, that's awesome. So that's why, but when you program in those devices, and you got to make sure that the size is actually very small, and yeah, so it's very portable. It's easy to manage.
Okay.
I know you can stay here. Yeah, so that's what the TensorFlow Lite is used for. Okay, so from today, we're going to actually look into the TensorFlow Lite because that's also going to be the tool we will be using for your actual project. Because we want to bring this prediction model on your phone so that we can run the prediction directly on the phone. We can even run some real-time prediction. So that's the goal we want to reach. So let's actually see how to use this TensorFlow Lite. Okay, so I think you're going to follow some of the links. There is one thing called a pick a model. Let me actually see which is the right link. And then from here, there's some kind of examples and examples. Actually, not here. Let me see, where do you start to train this one? Model maker. Yeah, we need to look at the TensorFlow Lite model maker. Okay, that's probably the thing you already opened, but let's just go through this one more time. And we are going to use the image classification. Yes, I think this is the one we're going to look at. All right, so could you actually open this link here? Let me actually send this link.
I opened it.
Perfect. Okay, so let's actually open this running Google Colab.
Wait, actually, I think this is a different one. Yeah, it's a different link.
Yeah, but that's fine. Let's see if you can get to the same page here.
I clicked running Google Colab, so it works now.
You could not run it?
I could run it.
Okay, so everything worked.
Yes.
Okay, yeah. Well, yeah, that the reason we want to use Google Colab is because it's actually easier for us to trigger it. Okay, let me know if you're on this page.
The prerequisites page, yes.
Okay, perfect. So I think this is something you already went through last time, right?
Yeah.
Okay, that's fine. Let's actually just use this one to review and then just see how things are working together. So what does this pip install TensorFlow Lite model maker mean?
Sorry, could you repeat your question?
But what does this line mean? Your understanding.
Let me go to it. They're just installing the required passages for, packages for TensorFlow.
Very good.
That's
Okay.
all.
Let's run it. Now, the cool thing about this one is that you just need to do one dependency package. It's called a model maker. And then this thing is going to trigger a lot of other dependency, including all the TensorFlow, a lot of other libraries we need. So they packed all of this together. So previously, you actually need to install quite a lot of things by yourself. Now you just need to do one thing, and then everything is included. All right. So but it's just the dependencies. Okay, nothing really special. All right. So,
All right.
yeah, awesome. And this part here, I'm not going to ask you because it's very simple. Basically, trying to import all the required classes and the libraries. And most of those are related with TensorFlow and then some of the model maker.
What does OS stand for again?
Operating system.
Oh, okay.
So
Okay.
I'll show you the main thing we need the OS is sometimes you need to access the files. So in Python program, if you want to, open the file, save a file, and then put a file, move around, and then put them in the folder. That's when you use the OS library. So the OS library is part of the Python standard library, so you don't have to download anything. It's always included in Python. But since like NumPy, TensorFlow, Model Maker, these are external library. That's why you need to do the pip install.
What's install?
So I'm talking about a pip install right here.
Oh, pip install. I'm sorry, I just heard it wrong.
All right, so I'm gonna run this one. It doesn't take any time, just import this one. Okay, yeah, give me 1 second.
Yeah.
All right, so let's move on. Okay, so these are just some kind of configurations and things you need to do in the beginning. Now let's actually move on to the actual training part. Okay, this part is actually pretty important. What's your understanding about this purpose?
Oh, I already ran the cell, but I know it's like supposed to import the file from Google. I mean, usually it's Google Drive, but in this case, it's not.
So it's actually download the whole data set because we're trying to run a training example and then download the actual data set. Have you tried to download this file here?
No, actually.
So why don't you do this thing here? No, we can run this one, you can run it, but it's going to download the file to the environment. But another thing you should try, Olivia, could you copy this link, put it into your browser, and then get the file downloaded? Can you do this one? If you've never done that one, you should try it.
Let me take a look at it.
Yeah, try it.
So download it basically.
Yeah. So you should have this file here. Are you using Windows or Mac?
Mac.
Okay, so if you have Mac, that's easier. So if you have this file, simply click on the file. It's going to extract all the files.
Wait. Okay, download it.
And then open the file to extract all the files.
Like click to open all of them.
Yeah,
Yeah, I'm still opening.
yeah, mine is also open. It's taken a while. I remember it was faster than this, but let's actually see. I just want you to see the things inside.
All right.
Do you have a lot of homework today?
Homework? No, I have a physics. I finished all of it except for annotations for English. I have like
Annotation. What does that do, Olivia? What
just
does,
writing notes in
okay.
the book, but I have to do 60 pages by Thursday and have a physics quiz tomorrow.
Okay, I see. Do you find physics easy or hard?
It's AP physics, so most of the time it's hard, even though I learned it 1 year in advance.
Mhm. Okay. Are you able to extract the file?
I opened it.
Oh, you open it, it should be a folder, right?
Yeah, I made 3 folders by accident already, but it's okay.
Can you tell me what's inside the folder? For some reason, mine.
Dandelion, daisy, tulips, license, sunflowers, and roses.
Yeah, absolutely. So there are 5 folders, right?
5 folders and 1 license, yes.
Yeah. So can you open each folder, see what's inside?
Okay. Pictures of each flower, multiple pictures,
Exactly. So
hundreds.
that's how they use this one as your testing data set. Okay. So there are a total of 5 flowers we can recognize, and every folder looks like they got a lot.
So it loaded for you.
Yeah, well, that's this example has prepared. They prepare this data set that has 5 flowers. Every flower you got hundreds of photos, and yeah, so that's basically what this data set is. So you want to know this structure very well, because later on, if we want to train your own model, for example, you want to recognize food, and then you want to have a folder for every one type of item you want to recognize, whether it's orange or it's apple, it's burger, all of this.
Yeah.
Okay,
Right.
so that's how it works. But anyway, let's come back to Google Colab. So this one here, it actually download it, and then it will know the path. Okay, it will know the path where that is, and then we should be good.
Okay.
All right, so let's go to here. Now, Olivia, again, try to explain what you think this does.
This, the one below it, well, it just loads the data, and as you said, splits data split into like 0.9. I don't know what the 0.9 is, but it's like classifying training and testing data.
Okay, could you explain to me why do we need to split this one into training data and testing data?
I think you need it for the third data set, like validation. Just, I guess it's for accuracy and stuff, but I'm not 100% sure.
Okay, so you hit a point. You're absolutely right. You mentioned about cross-validation. Exactly. So again, as a review, you probably already know it, but since what we're trying to do is we're gonna train a model to try to classify these 5 different flowers. And as we do the training, let's say like every folder has 200 photos. Okay. Now we throw all these photos to the machine learning model, the neural network, and they're going to train it. And then later on, we want to see how well the model is, how accurate. So if I give you a picture, which is a rose, and then I want you to tell me I want the model to tell me that is rose. Okay, so I need verification, validation to make sure it's accurate. Okay, so there are 2 ways I can do. I can just go to Google. All right, I can download an image. Okay, I would say a rose. And then I can just download one and then test it with my model to see if that's correct. And I can switch to daily and then download another one and then try it. Okay, so I can do that. But what I really want is something more automated. I don't have to manually download all of this. So that means I need some extra image to test. However, since in your folder, you already have so many images, I can simply pick one or two to just test it. And also the nice thing is I already know if this image is under the sunflower folder, this image is for sunflower. I actually know the result. I can use a program to test it. Okay, so I can simply just use these images as a test image to try with the model to see if it actually gave me the right results. Okay, so if you were doing that, Olivia, you probably already know that the best way is that if you want to use, let's say, this 5 images to test, well, then you should not actually include this into the training model when you do the training. Does that make sense?
How come?
Well, because Olivia, if let's say that there are 200 photos, actually that's more than 100. That's actually a lot. Okay, a lot of photos. Now I gave all of this to your machine learning model. They're going to train a model, and then I come back to use one of these to test. Now in this case, you should expect to have a relatively good results. Because your model has already seen it, right? You already told the model that this picture has this label. Okay, it's not a new thing the model has seen. So that kind of result or accuracy does not show you the real accuracy of your model, because your model already seen them, and you just want the model to see them. Does that make sense?
Yeah.
That's
so
why
it's lower.
Yeah.
Lower accuracy.
No, so it's meaning that if you use the existing images from the data set that you already being used for the training purpose, your accuracy actually will be higher than it actually should be.
Oh, so more data, the better.
Yeah, but what you should do is that if you want to use this image to test, okay, you'd better like take this out of your training. I'm gonna move this one outside.啊，应该有那个柜子里好像应该有那个，包括厨房那个柜子里找找就应该有，试试。Okay, I'm actually I should move this one out of the folder. So when you're doing the training, and I'll make sure that these ones are not included in the training process. That way, your trained model will not see any of these images.
Okay.
And then you actually use the model to test these 5 images. If your model still can give the correct result, that really truly shows your model is accurate.
All right.
Do you have questions about that?
No questions.
So that's why in the library, they have something called a data.split. So 0.9 means that I want to use 90% of data for training, and I want to use 10% of the data for testing.
Sorry, can you repeat the percentage for training and testing?
So you use a 0.9. That means 90% of the data for training and 10% of data for testing.
Okay.
That's what the 0.9 means.
Oh, okay.
So whenever you see the data split with this percentage, it basically means the same thing. They want to get you the right set of data for training only, and then the right set of data for testing only. You don't want to mix them, because if you mix them into the training, the testing won't be accurate, because you don't know if the model actually is really good or the model is good because the model has seen this done before. Everything you test with the model must be new stuff. Okay, so I'm gonna run this. That's gonna load all the images and then split them into two categories. You can see they already recognize the labels. Daisy, then Dylan, roses, all of this because of the folder name. Because of folder names.
Yeah, they recognize it because it downloaded on our Macs.
Exactly. All right, so let's move on. How about this part? Step 2.
Just trains the data. That's
exactly. All. So this is always the most important line of the code, and it does all this magic. They basically use TensorFlow model, and they use, I think they have multiple layers. Again, this is too much detail. That's that we basically use the TensorFlow Lite models to do all of this training. So it's going to take some time, but it's not going to too much time.
Okay.
Yeah, please do the same thing on your end as well.
Yeah, it's still running for me.
Okay.
What's epoch again? Is it like Keras or something?
Yeah, it's a good question. Let's actually Google it. I actually forgot. Yeah, so it's kind of like an iteration.
Okay.
So one approach means that each sample in the training data set has had an opportunity to update the internal model parameters. So we're trying to train and build a model. Eventually, we're going to generate all the parameters for the model, but it's not like a one-time thing. You actually need to go through these things multiple iterations, I think, to iteratively improve the model. So I think that one approach means like one iteration.
Okay.
Yeah. All right. Well, this is done pretty quickly, actually. This one only takes 1 minute.
It's almost done running for me.
Okay. And then you really want to see at the very end, they show you accuracy. Because you already specified the training data and the test data. So they can use the test data to get accuracy right away. As you can see, the accuracy is pretty good. In the first iteration, it's not very good, 77%. And then at the end, you actually get a 93.75 accuracy.
I got a 93.51 accuracy.
Yeah, I'm not sure if this is everything time is different. And it could be because some of the, but it's not going to be changed too much. For example, one of the approach we call like a random forest, and that one also has some kind of random.
Oh, is it like this decision trees?
Yes. Yes, in the decision trees, there are one thing called a random forest. That model actually has some kind of random, parameters there. So you might get a slightly different accuracy, but it's not going to be too much.
Okay.
All right. So from here, let's actually move on. So after training, this is to evaluate. And that one actually, I think the test data to do this something one more time. And then you got accuracy for 91%. So again, I can't explain what's the difference between this evaluation than that direct evaluation, or maybe this one doesn't need the real test data. This one does use the test data. Maybe this one didn't use it because this one I think we didn't pass it yet. We only put in the training data. This accuracy probably was not done using test data. That's why it's higher, because you are just testing with you already have, or it's supposed to higher.
Okay.
All right, so that's it. So you train your data. Finally, very important, we need to export the model. So let's actually run it. and see where the model got actually.
I'm running it right now.
Perfect.
Still loading. Oh, it ran for me already.
All right, are you able to locate where the model is?
Yeah, it's above detailed process, like right above.
So I mean, where do you know where to find those models file?
Model files.
Yes.
Where? Not that sure.
Right. So that's the main thing we need to actually find out, because once we export this T file, TensorFlow Lite file, we need to get it and then we need to put it into our app eventually. Okay, so let's actually do some research. I'm actually trying to find here. Oh, here it is. So the model file actually goes to here. So Olivia, can you actually open this file here?
I got it. Open.
Yeah. All right. I don't think you can open it. It's just a compile.
Oh, yeah, but I got the sample data.
Yes. So then
Wait,
we also
it says Ask Combi's data set. Is it like 4 data sets? Can you like reiterate what it is? I learned it, but I forgot about it.
I'm sorry, Olivia, what was your question?
Oh, I just saw something called Anscombe. I think I learned it before. It was like 4 data sets, but I forgot what it's about. Can you tell me what it is again?
Where is that? Sorry, I don't see it. Which part?
It says it's the second one. It says Anscombe. Like from the sample data.
Sample data.
Actually, from the file. Actually, it's okay. It's not important.
Where I don't see it. Can you do a annotate on my screen?
I can't do that because I'm joining from web browser, but it says it's below README, like the file.
Oh, this one, right?
Yeah.
Okay. This one. No. So this one has nothing to do with this project, because I think some of this, like this one, the California housing, that's a different data set. These are just some different data set. As you can see, they call it sample data. This one had nothing to do with our, with our this flower recognition project. This one just gave you some kind of California, housing data set you can try to play around with. Probably test some of these machine learning functions. I assume this is also something similar.
Okay.
Right. Yeah, don't worry about it. It has nothing, it's just some kind of data set, nothing technical. All right. So another thing we should figure out is the labels. There is another file called a labels file. So that's the part I got a little confused on where to find this, because we actually need to download this one, because this file here, if you click and download, that's going to work. This model is very important. That's the thing you actually generated after all this training. Yeah, so that's one. Now we need to find out the labels file.
Okay.
Oh, I see. So label file is inside the TensorFlow Lite model file. Oh, really? Okay. I think they changed a lot. Yeah. Previously, they have the label file separated, but now they actually move it back to the model file. That's fine. The label file pretty much has all the names you actually generated from the folders, the 5 names. That's what the labels are.
Okay.
All right. So, Olivia, I want to, I think we actually repeat this part here, but you need to know this part is so important. Okay, because we need to run this on mobile. So that's why we choose TensorFlow Lite. TensorFlow Lite already has an algorithm. What we need is get the dependencies ready, import them correctly, and get the data set ready. This is so important. You need to have the right data set for this. And then we can put them into loaded and then split them for training and testing purposes, create a model to train, and then we're good to go. And then we can evaluate the accuracy and then we can export it. And of course, you can also call the model to use a model to run the prediction.
Okay.
So, any questions so far on this part?
No, but where is it? Is it called evaluate the customized model? I actually never mind. I found it.
Okay, all right. So down below here has detailed process. I think this one just talked a little bit more about this whole process. Let's just quickly go through this one. This one here explains how you actually prepare the training data set. So this part, again, very important, okay, Olivia, because later on, when we want to prepare our model, you just need to create more folders with the model name and then add image inside.
Okay. Yes.
Okay, and this part here, I think it does the same thing. Yeah, I don't know. We need to rerun this. Yeah, it's already done. It does exactly the same thing. This is just trying to explain everything, right? So this one they use 80% 20% for testing. All right.
80% for training, and then for the second one. Can you explain the second one?
So you see, look at this line, okay? 80%
Yes.
go to the training, 20% go to the rest data.
Yeah.
Rest data, they split in half and half, and half of them for validation, half of them for test.
Yes.
So the question is, what will be the difference between validation and test? This is actually the first time I see it. So let's actually see the code and let's figure out what's the difference.
Okay.
So this one here is trying to show you what the data set looks like. I don't know if you ran this one last time. Let's just run this code.
I pressed run all, but it's taking too long to run, unfortunately.
Yeah, no problem. So this one actually load how many? Yeah, they actually get 25 pictures from each folder and then try to render them so that you can see what each model looks like.
Okay.
So they actually apply the validation data here as you do the training. Let's see if you see the difference.
Actually, it's loading some of it for me. Yeah. Still not done, but I will wait for it to load.
So I have to say that this training actually is not bad. It's actually pretty fast. So I'm wondering
I
later
see.
on when we have more images, if that's going to take even longer. You know, I can't really tell, but one thing I see here, Olivia. So previously when we did the training, we only provided the training data, but now we're also putting the validation data here. I think that's how you can see here. I think that's how they start to do the validation right away. That validation you can see compared with the accuracy here, that's different. So the validation result is lower than the accuracy, but I think the accuracy did not use any of the.
Okay. What would you say the fast time to like run the cell for it to,
Sorry, you're asking what could be the fastest time we can use to do the training?
yes.
You know, that's mainly a question on how good your computer is. So that's another reason we do this thing in Google Colab, because Google Colab has everything for us. So you can even do, I think they got a pretty good CPU here. Let's see how do we change. I think change like GPU. I think yeah, we're probably already using GPU. That's let me see. So I don't know if we can configure this, but there are definitely ways you can get a better GPU, or you can pay more to get a bigger version. So that option is definitely available. Okay, anyway, so this process is the same thing, but this part here, as you can see, it gives you a lot more details to see, you know, what's going on with this whole process. And then this one, they call the model summary. Yeah, they just talk about the whole like training status, how many images processed, how many parameters. And then they have evaluation. So this is evaluation, the same thing as we've seen earlier. It just uses the test data. And then finally, this part here, I think it just gave you a nicer view for the testing. So let's actually run this. All right, so Olivia, can you see this one on your screen?
Yeah, it already ran for me.
Okay, so this obviously they're trying to input all these images and then use the model you train to predict and tell it's correct or wrong. Okay, but this example is very cool because actually it shows you how you run the prediction on each photo with the trained model one by one. And are you able to point out which line of code actually ran the training?
Line of code which runs the training.
Yeah, calls for the prediction.
Predict label I00 line 21.
Oh, this one, yes. Well, that is a result. The line to trigger the prediction process should be this line here. This one.
Oh, predict that one.
Yeah. So you see, they call it a model dot predict top K, and then you pass the test data. And then the top K, I assume that, as you can see, K is the number of the top results to be predicted. Okay, so let's actually do this. I want you to actually see, let's see, print.
I have a question.
Yes.
What do you call the function get label color?
Get label color. No, you don't. I think it's actually right here. You set the color.
Oh, that's where you call the function because you need a call for it to run.
Yeah, you set the color to be either default or a red. Okay, but let's take a look at this part here. Okay, if you print the predicts right here, I'm gonna run this again. All right, did you see this one here, Olivia?
Yeah, it already loaded all those
So
pictures for me.
no, I'm not talking about picture. I added one line of code. Did you add it?
I'm adding it right now.
Okay. All right. So are you able to see this line here, Olivia?
It's not finishing, like
Oh,
running for me. Yeah.
but
it's
just looking
crazy.
at my result here, can you explain what this line means?
Isn't it like the types of flowers, like 5 types, dandelion, tulips? It's actually not the 5 types. It's in order of what they appear, like, and then the accuracy percentage and the confidence interval.
Very good, very good. So because you're trying to predict, okay, all the test data together, this one is actually a bit. So this one shows the result for every single picture. And it shows the type, the label, and show the confidence. Okay. Now, as you can see, it actually predict top K. By default, it said, I think it said that by default, the K is 1. So if you change the K to
The K folds.
no, it's not really. So you see the screen here, K means that the number of the top result to be predicted. So if I do K equal to 2, and let's see the results. Okay, see, every record, you got a 2 results. Does this make sense?
Yes.
And then obviously, the first one has the highest confidence, the second one has a lot lower. Okay, so that's how this predict top K works. By default, it's just K, top 1. So K equals to 1.
Okay.
All right. So I'm gonna clear this. But what I want you to see is that this line is actually pretty important because you got a model, you can predict some kind of a data set, and it's going to give you the results. So later on, when we program this in mobile, we're going to do exactly the same thing. Once we have the model there, we will need to actually call the predict and then get the label. And then we're going to pick the, the highest confidence.
Okay.
All right. So any questions here?
No.
Okay, so let's actually pass this one here. And then finally, this is part of the same thing. So yeah, so this one here talk about export, but you could actually, oh yeah, I see. So this is how you can export other things. Like this one, it's going to export the actual model, and then this is going to export the label. We're going to try this one later on. Yeah, the exporting definitely takes longer than I saw. So anyway, this should still generate the file, but if we do this, it should give us the label file. So let's see. All right, so here we go. So it can also, by default, I think everything already incorporated here in the file, but you can also see the final labels file. This one, if you download it, it's very simple, basically just a bunch of the screens.
So I'm gonna download it right now.
Yeah, this one here, that's the label file, just with all its names.
Oh, that's all.
Yep.
Okay, I got the names.
Yep. All right. So yeah, and finally you can evaluate this file again, but that's not too important. All right, so let's see some other things. They have a create function and a transfer learning with a predicted model. So we probably don't really need all of these ones. And okay, so we will. All right, so yeah, Olivia, that's pretty much all about this one. Now, this Google Colab process is so important because we're gonna use this one as our base to do the training. Every time you create new models, you will need to come here to retrain it and generate and export the files. And then we put those files into your app. That's how your app can work.
Okay.
Does that make sense?
Yeah.
Yes. And then the main thing we need to figure out next is that, okay, if we know this, how do we train our own model? Okay. So
Okay.
that's why I want you to know how this folder structure is. Okay, if you know this one, and all we need to do is create a new folder. Okay, and then put a new file there and then put it back here to retrain it. Okay, so let's see if they actually create something with it. So you could find the upload button in the left here. And
Yeah, I found it.
upload the file and zip it. Okay, so looks like if we want to follow this one, we just need to use a zip file. So why don't we give a shot here, okay, Olivia? Could we actually create a new one? You can choose any kind of type you want. I'm gonna use soccer. Okay, you do your type. Okay, let's do different ones.
Wait, I'm gonna go to it. Where's it download?
I'm sorry, Olivia, what did you say?
I'm trying to open a new folder. Really.
Okay, yeah, so I'm gonna get some soccer images and then you choose your object you want to work.
How do I open a new folder? It's not really letting me.
How do you open a new folder? Or in the file, I just create a new folder.
Oh, I have to locate the files.
Could you share your screen? I can see it.
Yeah. go to documents. Oh, new folder. Yeah. Okay, I got it.
Okay. Okay, so let's quickly get about like 30 images. Okay, 30, okay.
We're down 30.
Yes,
All right.
the more the better, but let's just start with.
I did dogs, by the way.
Okay. So how many images do you have now?
Like almost 20.
Okay.
Still not enough though.
All right, I think.
Wait, I have 18, but I don't think I can download anymore, unfortunately. Let
That's
me
okay.
try
Let's actually
again.
just use this one. Let's see if it works. Okay. So let's put everything here into the actual folder. Okay.
I already put it into my
Yeah.
phone.
And then in order to make things faster, I'm going to delete two types. I'm going to delete the sunflowers and the tulips. That way we're not going to be running too slow. So I'm going to delete those. Okay. All right. And then can we actually make a zip file first? So I think you will need to create a zip file for the actual folder, for the flower photo folder.
Actually, I was able to get more. Something just happened. I have like a little over 20.
Yeah, so we're gonna make a folder. We'll still call it flower photos. Okay, that's here to manage. And then we're gonna make a zip file. Can you make a zip file with this folder? Okay, something like this.
Can you re-demonstrate how you do that? I have 25 now. I'm just gonna stop at 25.
All right, why don't you share your screen?
Yeah, okay.
Could you actually share the whole folder, so whole screen? And I'm only seeing your file folder here.
Oh, wait, let me try and change it. Like this.
Yeah, so you actually go to find the folder.
Okay.
So just docs.
Yeah, dogs.
So I mean the folder that has all the subfolders. So you only have docs. Well, can you go up, go back? Go back. Can you open the flower photos? Which one has the new one you created?
This one's new.
Yes.
Actually.
So did you do docs? Can you move your docs folder to here?
Yeah.
Yeah.
I'll find it here.
Just copy it. All right, could you delete 3 folders down there so that it's faster? Delete 2 or 3. Okay, now go back to your download folder. Yeah. Now, could you delete the flower flow photos below? Delete that one so that you can rename your photo two to just flower photos.
So delete this one.
Yes. And I rename the first one.
Okay.
Okay, can you right click on the folder and then compress it? All right, now let's actually try to get the zip file uploaded. Okay, don't open it anymore. You can now we need to upload it to the Google Colab. Okay, so I'm gonna go back to Google Colab and then let's see that we want to upload.
Can you say this thing again?
So to upload the folder back to Google Colab. Could you try the upload?
Yeah.
Okay. Once you upload, let's see if we can use a new one to actually retrain everything. Okay. So obviously the key here is to know how the path works.
Open flower photo zip, right?
Yes.
Okay. Got it in. Do I need to change that cell below get data path?
So I'm trying to figure this out. Okay, so let's see what's the best way to do it. I think we can do it in an easier way. Okay, we need to unzip the file. So let's actually see how to unzip. All right, so Olivia, did you see my screen?
Yes, I see your screen.
So, okay, so this is how it works. So you upload the zip file. Now we need to extract it. In order to extract it, we need this command called unzip. So I'm gonna do this one. So like if you just do this, unzip, and then put the file path, that's gonna unzip everything. As you can see, after unzip, it's gonna have all the folder ready. And then after that, all you need to do is that this one.
I think I made a mistake. Wait, can I share my screen?
Yeah, go ahead. 按着说，快点玩，5分钟已经过了。
So I cannot find the flower one because there's so
yeah,
many.
it's under content. Yeah, that's a little confusing. It's content.
Oh, okay. I was wondering like, where it
Yeah.
goes so many files.
Yeah, that's okay. And then what you want to do is that from yeah, so let's actually go to this part here. Let me see. Mhm. Oh, I can't actually do annotate for some reason.
That's because I'm on web browser because my Zoom doesn't really work
okay.
on Mac.
I see. Okay. All right. So yeah, so basically, okay, could you follow me?
Yeah. Well, I'll stop sharing actually.
So if you're under here, so we this time we don't need a file path here because we're going to provide a file path. Okay, you just need to comment on this part here, and then you need to do unzip, and you do this sign here unzip, and then you need to get your zip files path. Okay, you can do this by clicking on the file. My screen, click on the file here on the right. There is a copy path, and then you put it right here.
Okay, got it.
And then if you run it, you should be able to see these things here. Okay.
Oh wow, it runs, but it's so long. It went with inflating. Yeah. It's the same thing as.
Yeah. So after this, Olivia, can you go to this block here? This one, right here. Okay. Now we're gonna do an image pass equals to. If you see the folder right here, do the same thing. Click on here, copy path, just get a path.
Okay.
So that's how we hard code that thing. Okay, and then we run it. It's gonna load it. So you should be able to see the label you just put inside the folder.
Wait, there's an error on my screen.
Okay, show your screen. So image pass. And you do not, let me see. So the image path should not be a zip file, I think. The image path is the one you extracted, it's a folder. So you need to pass the folder there, not the zip file. So click on the flower photos folder. Yeah, and then copy path. And then put those ones here. Okay, could you try that again?
Yes, it works.
Yep. So now finish the training.
I'm running the cells below that cell.
I'm sorry. What did you say?
I'm just saying I'm running the cells below that.
Right. Okay. Yep. And then this one should work as normal. Okay. So that's basically how you customize it, Olivia. So for this week, could you actually prepare 4 different objects or food you want to recognize and use this approach to train them? And so that next time we can start to do some experiment, or maybe we can start with a mobile.
Oh, I already did that, but more than 4. Can I show my screen?
Yes.
Because Marissa told me to do a lot, but I think I didn't count how many I did, but I want to be as specific as possible. It took a really long time to run.
That's good. That's good. So this part here, you
19.
Yes, but then are you able to put all the images together into the folder?
Well, how do I do that?
Well, that part you got to figure it out, because I already showed you. You can download all the files, put them into the zip, and re-upload it. So use the things we did today, because that's what I was trying to show you. You download the folder, you create a new folder, you put the files in it, and then make a zip file, re-upload it, and then unzip, and then retrain it.
Can you repeat that? I need to put in the comments so I remember.
Okay, so I'm gonna send the video today, what we did. Step 1, you need to, in the local, you need to get your folder ready.
Okay.
And then you need to, for each folder, you need to put enough images.
300 is enough, right?
Yes. And then you make a zip file for the whole folder. And then you upload it back to Google Colab. And then you run the unzip command and retrain everything. If you don't understand how this code works, I would recommend you just do it with the approach we showed you today, by manually downloading the images. Okay. You gotta make sure know how to actually customize the data set and retrain everything every time.
Okay.
Later on, we could actually figure out this code here. She gave you that make this process simpler. You just need to, run the code, download image, and then retrain it.
Okay.
All right. So try it. Once you get a model ready, we should actually start to move on to the mobile development next time.
Okay, sounds good.
So we can really try it on the phone. All right. Sounds good, Olivia. Yeah, I'll put the video there, and then I can also send it to you.
Okay, thank you.
All right. Okay, do you have any other questions?
No, but happy Lunar New Year.
Yeah, same to you, Olivia. Are you guys doing anything special?
Oh, we just ate a lot of good food, that's all.
Okay, all right. Okay. All right, Olivia. I will see you next week.
Okay, see you. Bye.
Okay, bye.